Welcome to the latest episode of the MFG Radio Network's Lunch and Learn, as we highlight some of the latest advances in manufacturing and design, gain insights about the newest products and technologies to move your manufacturing ahead of the competition. Hello and welcome to GIE Media's latest Lunch and Learn. I'm Jake Kaufman, an associate editor for the manufacturing group here at GIE Media. We'll get right to the presentations today as we are joined by Zeiss. Zeiss is an internationally leading technology enterprise operating in the optics and optoelectronics industries with four key segments: industrial quality and research, medical technology, consumer markets, and semiconductor manufacturing technology. Zeiss develops, produces, and distributes highly innovative solutions for industrial metrology and quality assurance, microscopy solutions for the life sciences and materials research, as well as medical technology solutions for diagnostics and treatment in ophthalmology and also microsurgery. Today's presenter is Trevor Campbell, an industrial microscopy product manager at Zeiss Industrial Quality Solutions, where he leads the light and electron microscopy business for the North American market. Today's presentation is called Correlative Workflow to Identify the Root Cause of Particle Contamination.
So what is technical cleanliness? Technical cleanliness is looking for contamination anywhere in the manufacturing process. This is to ensure quality and durability of components. You're looking for things that might cause early wear or failure inside of specific parts. Could be anything from metal burrs that might cause damage inside of a moving system, or it could be things like conductive particles in electronics, which can cause shorts and early failure. So these end up causing a lot of headache in the manufacturing process and for the manufacturers with potential recalls or just damaged parts that are wearing out a lot sooner than expected. So this is something companies are more and more trying to do inspection for before they're shipping critical components out to their customers to prevent them from coming back early and potential issues with the product. Typically, parts are washed and you're looking for particles on the filters that are being filtered inside of these cleanliness cabinets. So the idea is that you want to detect those particles either in a manual or in an automated fashion to where you can detect the different parts of types of particles that might occur anywhere in the manufacturing process. You might be looking for things like hard particles, like metallic particles, minerals, or ceramics, or things like soft particles like fibers of polymers or cellulose. Also things like electrical conducting particles such as steel, copper, and aluminum. Once you've located those particles, it's important to analyze the size, as many of our industry standards, like the ISO standards and VDA standards, require sizes be taken on these particles and then categorized based off of size ranges. So typically a user will specify what ranges they're looking for. Many of the industry standards have that specified for them and have limits for the amount of particles within those size ranges that are allowable on a product. So once we've sized them, we can categorize them and bin them accordingly. So what might you be looking for? For component cleanliness, you're typically looking for three major things: metallic particles, non-metallic particles, and fibers. These typically get classified by whether or not the particle is shiny or not. And we're able to determine that by using polarized light. Depending on the angle of polarization, a metallic particle will either look black or it will look reflective. So under one angle of polarization, it'll be one and one will be the other. And between those two images with different polarizations, that's how we determine whether something is metallic or not. Many of the industry standards are calling out for that because those get categorized differently than, say, a non-metallic particle or a fiber. Other things that you might be looking for are non-metallic particles. These could be things like plastic chips, residue from the manufacturing process, paints and lacquers, things along those lines. Along with component cleanliness, there's also an oil cleanliness procedure. This is typically done in engines or hydraulic systems, where you're trying to look for debris that might be coming out of the system at an earlier rate than anticipated. So you're filtering that oil and analyzing it in a similar way that you might for component cleanliness. Medical device also does some of the things along this line too, along with medical drug delivery, where you might be looking for particles for an FDA or USP standard. And then you also might be looking for things like environmental cleanliness. This is typically filtration of air in something like a clean room or somewhere where parts need to maintain sterility. So you're looking for things that are in the air where these are being assembled and manufactured that could end up on the finished good and delivered to a customer. So where are you typically finding this kind of contamination? You might be looking for particles that are in moving systems, say ball bearings, or systems where things are moving inside of them, like injection nozzles. You don't want that debris being fired into an engine, some sort of combustion chamber. You're also looking for particles on electrical contacts and circuit boards. Specifically, this is a very big issue in the new energy electric vehicle space because the particles can cause shorts in the boards and cause failure of the entire vehicle. As I noted earlier, oils and lubricants are another big area, as is drug delivery and implants. So what industries are typically doing technical cleanliness analysis? A big one for us is automotive and e-mobility. This could be everything from fuel injectors on standard internal combustion engines, all the way up to battery control modules on the electric vehicles. Implants are a very rapidly growing market for technical cleanliness analysis because you don't want foreign matter ending up inside of the body. Additive manufacturing is another one as well, specifically for checking the powders and the prints to make sure that nothing is being deposited that shouldn't be there. And also aerospace, things like turbines, where there's a high degree of accuracy that needs to be achieved. Same with injection nozzles and things in that industry as well. Another area where you're looking for component cleanliness that has a high degree of accuracy. What standards does Zeiss work with for our TCA analysis? The big two are ISO 16232 and VDA 19.1 and .2. On oil cleanliness, we have standards for ISO 4406 and 4007, as well as NAS 1638 and SAE AS 4059. We are also part of 21 CFR Part 11 for the FDA regulation. Zeiss actually has a module available for its software that we call GXP, which stands for Good Manufacturing or Good Laboratory Practice. And this is a traceability module that can be implemented into our software and into the technical cleanliness process that makes our inspection process fully compliant with 21 CFR Part 11. This is actually unique to Zeiss. We're the only microscope manufacturer that has the ability to offer that level of traceability. So the standard process for doing component cleanliness is that you're starting with the components that you've just manufactured. They typically go through some sort of a washing and cleaning cabinet where you're spraying the parts off with a detergent, and then that detergent gets filtered onto a standard, typically 47 millimeter membrane filter. Once you have that filter is then placed inside of a holder and inserted underneath the microscope. From there, we can use a motorized stage and tile the entire field of view of the filter together, which then will undergo a segmentation process between both the polarized and non-polarized channels to where we can determine whether something is a particle, whether it's a fiber, whether it's metallic or non-metallic. And then these will get binned based off of the size constraints that are indicated in the specific standard you are working with. And from there, we actually have the ability to take that entire filter holder assembly and place it into one of our Zeiss scanning electron microscopes using a capability that we call correlative microscopy. There are little fiducial markers on the filter holder that our electron microscopes can read and know the position of both the holder itself as well as the filter and where the particles are on the filters. So if you've located something with the light microscope, you can then jump right to that particle on the electron microscope and run your elemental analysis to determine whether something might be conductive or not, for instance, if you're looking for something in the electronics or electric vehicle market. We have 4 different light microscopes that we offer this capability on that have a size inspection range anywhere from 50 micron particles all the way down to 1 micron particles. This depends on the stage being used and the optics being used as well. Our Axioscope 7 has a very nice compact motorized stage built in that can do up to 50 micron particles. Our Discovery V8 stereo microscope can handle up to 15 micron. The AxioZoom V16 can go down to 5 micron, and the Axio Imager 2 can get down to about 1 micron particles with the correct lenses. From there, we're able to transition into our scanning electron microscopes. Typically, this would be done under our Zeiss Evo microscope. This is our conventional scanning electron microscope. It has either a tungsten or a Lab 6 filament and can be equipped with any number of different particle analysis detectors that run our Smart PI software, Smart Particle Investigator. Very intuitive software designed to be able to easily detect your particles and do the elemental analysis to give you that chemical composition. This can also be done under our field emission scanning electron microscope, the Zeiss Sigma. So the big idea behind our process here is to be able to work seamlessly between both those light and electron microscopes. Zeiss is the major player in both of these modalities of microscopy, and we're the only one that can go seamlessly between the two using that correlative microscopy that I talked about earlier. So you won't need to hunt around your scanning electron microscope field of view to try to find very small particles. We can jump right to the ones that we've already identified and characterized using that light microscope. So the idea behind the analysis is to know that root cause faster so we can make the right decisions and come to these conclusions quicker. The way that we do this is through our technical cleanliness analysis software. This is a very user-intuitive workflow where your operator will be guided through this process, and much of this will be automated. This is a fully XYZ motorized system, all 4 of the light microscope offerings. And much of this will be automatically segmented for the user, especially if you're running very similar filters all the time. They really won't need to adjust much of that segmentation thresholding at all, because if you're looking at similar particles all the time, it's already got the correct thresholding in there. So you'll be able to work through this very quickly. The process to do so is just loading that filter into the holder. You'll establish your focus point, and then it'll go ahead and start tiling that image and running the segmentation and binning of the particle sizing for you. You do not need to be a highly skilled microscopy expert to be able to run this microscope and the analysis software. What sets Zeiss apart from everyone else doing technical cleanliness is specifically our camera technology. The way that we do our scans is actually with a polarized light camera. So for those of you who are familiar with polarized microscopy, the camera is actually acting as the analyzer in this system and is able to take all 4 angles of polarization transmission while taking one singular image. So we do this doing only one scan of the filter in comparison to our competitors who are doing several scans to get different angles of polarization. So we can take the 0, 45, 90, and 135 degree transmission directions all in one single step. So for every field of view, it's going to take those 4 images for you, which is going to cut down on scan time significantly. So you don't need to shift between bright field and pole. It will just run one single scan across your entire filter. And you can see images below there at the 90 and 135 degree channels. This is how we differentiate whether something is metallic or non-metallic. It would show up as the same in both if it's a non-metallic particle. So once we have identified those particles, you can see some screenshots of how we're able to review. So it'll show you a gallery of your largest particles. So you can go ahead and review whether those were correctly captured or not, double check that they're classified correctly as a fiber, or maybe you had overlapping particles that you need to segment, just to differentiate whether it's a single or actually two different particles together. You can also set it to automatically capture particle height on some of these particles as well. So if not just XY dimensions are important, but also volumetric measurements where you need to know height, that is something we can also do here. We've also recently added a machine learning capability into our technical cleanliness analysis software. And this is to help differentiate specific types of particles that maybe have a difficult time being picked up under polarized light. Like very, very small metallic particles can sometimes be hard to polarize correctly. And also metallic particles that have been oxidized. These often don't have reflective qualities, so they can be a little bit difficult to recognize through polarization. But typically, users and companies will know what particles are oxidized, and we can train the software using machine learning and artificial intelligence to know what these oxidized particles look like, so that we can better classify those as a metallic particle when the software may initially find them as non-metallic because of the lack of reflectivity. So this enables a much better accuracy and reduces miscalculation of metallics, and greatly adds in time savings of having to review this stuff manually. And once you've trained this model, it'll implement that into future scans. So you don't have to go through and review that each time. You will teach the software what they look like, and it will automate that for future filter scans. TCA software is also part of what we call our connected laboratory. We have a handful of different modules that are designed to be able to integrate all of your microscopes together to make sharing data much more seamless and fluid. These are both our Zen Connect module, which enables you to share data back and forth easily between the light and electron microscopes and do that correlative analysis, but also things like our Zen Data Storage module, which allows you to communicate with all of your microscopes across a facility. So if, say, your light microscope is in one lab and your electron microscope's in a completely separate lab, maybe you even want to tie that into some data from, say, a confocal system for doing some surface analysis and maybe some images off a stereo microscope. We can blend those seamlessly into one report together because we can centralize that data storage between the systems and make it so that you can share images and analysis back and forth very rapidly and seamlessly. So some key takeaways from today's presentation. One is that with our OneScan technology and that polarized light camera, we're able to do this particle analysis much faster than competitors because we're not having to do multiple scans across the filter. Two is that we have new standards and traceable workflows built directly into the system, specifically for medical device and drug delivery manufacturers. That's our GXP module that I talked about earlier that allows you to be fully 21 CFR Part 11 compliant. Number three would be Rapical particle inspection workflow between both SEMs and light microscopes using our correlative microscopy. We also call that shuttle and find if you've ever heard that terminology before or see that in any of our other presentations. Number four is our collective laboratory structure. Will enable you to easily and seamlessly share data between all of your microscopes, and even third-party images can be imported. I should note that. And number five, we have a new approach with object classification that utilizes machine learning to help reduce time from misclassified particles. And six, Zeiss is a one-stop shop portfolio for fully correlative from light to electron microscope workflows. So we are able to help solve these issues that companies might be facing with particle analysis problems much faster, because our scan times are significantly reduced, and we're able to go back and forth between light and electron microscopes to do the elemental analysis faster than anyone on the market.
Well, thank you so much for the presentation, Trevor. Now it looks like we do have a few minutes for some Q&A. So I will start the discussion if that's all right with you, Trevor.
Absolutely.
Awesome. So first up, now you obviously talked a lot about the TCA software. Can you customize reports in TCA software or the Smart PI software if you're not using the listed standards?
Yes, any of the reports can be customized because not every customer is working off of a specific standard. And we've even encountered a couple of unique standards that we don't have fully implemented yet that we've adapted reports to do. One of those is USP 788 that gets used very often in drug delivery. We've had a number of companies making syringes and diabetes medication and inhalers, and they need to clean those medical devices and then check them for particles. They have their own classifications. We've built some reports around that. Some companies are just doing sort of their own criteria where they've got their own standards that aren't one of the common industry ones. So, yep, anything can be adapted to fit a company's needs when it comes to the bin ranges or, say, the max allowable particles per those size ranges.
Okay, awesome. Thank you, Trevor. Now, also when it comes to the TCA software, are you able to upgrade existing Zeiss microscopes to add the TCA capability?
Yes, a lot of the equipment can be reused on one of a customer's existing Zeiss microscopes. In fact, we just did that at a customer just a few weeks ago, where they already owned one of our Axio imagers, and we swapped out the camera and software, and we're able to do that upgrade in the field for them and work with them on their full particle analysis solution. As long as you have one of our sort of encoded microscopes, whether it's a encoded stereo microscope or Axio Zoom or say our Axio Imager, we can upgrade it in the field to add this capability.
Awesome. Well, thank you so much, Trevor, for the presentation today. I know a lot of people are probably going to be asking plenty of questions about the TCA software. So once again, thank you for the presentation, and thank you for Zeiss for helping us put it on during today's Lunch and Learn.
You can find more Lunch and Learns plus the MFG Radio Network's other podcasts on Apple Music, Spotify, Google Podcasts, or on our websites at todaysmedicaldevelopments.com, aerospace manufacturing and design.com, and evdesignandmanufacturing.com.